Hello everybody and welcome to MACH 2024. We've got something a little bit different for you now, haven't we? We are on a stand, but we're going to have a little bit of fun first. You up for it, Chloe?
Yeah, I'm well excited. Can you tell? I'm really excited.
Here we are. This is Dean. He's very posh. He's from Windsor. And, and he's a magician. Did you know that we were going to do this 10 minutes ago?
Yes, they told me literally 10 minutes ago, so I'm excited to be here, and I'm happy to show you some close-up magic right now as well.
Brilliant. Just a quick one, we are on the Starrag stand. Any messages or comments if you want, send them in, because what we're going to do is have a little bit of fun, then we're going to have some more fun and take you on a tour of their stand, find out their story, what Starrag provide to industry. You're going to be going a little bit more technical with one of the gents as well, Chloe, and then I will afterwards, so we'll be passing on the baton. Right, okay, let's go, Dean.
Brilliant, thank you very much. So the first thing I've got for you is a few of these old shopping receipts here, okay? So I've got 5 of these receipts, and I'll tell you what, Lindsay, can I borrow your finger for a second? That'd be okay. If you pop your finger just a little bit lower down, that'd be perfect. These 5 receipts, all I need from you, Chloe, is any magical words in the world except for abracadabra, because I've heard that a few too many times.
Oh my gosh.
Today. Any magical words?
Flash.
Flash, very good. That's unique as well. Look, on your finger, 1, 2, 3, flash. There we are. They change into £100. Thank you very much. Well, I don't know where the receipts have gone, but I'm more
oh my gosh.
kind of interested in the
That was in a flash, wasn't it?
It was indeed, yeah. Very good magical words.
Thank you.
I appreciate that.
Can we not have that?
I'd love to give them to you, but I need to return them to the man I pinched them from over there earlier. So we'll move on to, this is the world's fastest card trick using 52 shuffled playing cards. I'll show you they're all shuffled around in a random order. We have clubs, hearts, spades, diamonds. Can I ask you, please, Chloe, to take out any playing card whatsoever? Anyone whatsoever? No, not that one. It's too obvious. Anyone whatsoever. Please go for anyone.
Sorry. Thank you.
Okay, have a look at it. Make sure everybody else around you sees. I'll turn away so I cannot be accused of cheating in any way, shape or form. It goes roughly back inside the middle about there. That'd be great.
Thank you.
Okay, now do not forget the card. If you forget the card, it'd be a rubbish end of the routine for me. So here we go. Look, one card flies out of the pack. There's 7 somersaults in the air, and it is, believe it or not, the Queen of Spades.
Way!
Was that your card?
No.
Oh, right. What's your a little bit embarrassing. We're live as well, aren't we?
Sorry.
Look, if you watch the Queen of Spades up here, if we give it a little shake, it looks like it changes.
Yes.
From the Queen
Oh my God.
into. Was that the one you chose, right?
Yes, it is. Yeah.
Now you could have gone with any one of the 52 cards. I'll show you. They're all shuffled around in a completely random order. We're going to take the 5. The 5 is going to go inside the middle. Like I was saying to you, this genuinely is the world's fastest card trick. So if I take the 5, place it all the way inside. Can you give it a little snap over the top? Would that be all right, Lindsay? And turn that top card over for me. You'll see it jumps from the middle back to the top.
That's magical.
Now you know what's about to happen. The last time it will go somewhere from here all the way inside. So if you could place it all the way inside. Lindsay, one more time. Just push it all the way in for me. And snap your fingers. Here we go. Look, oh, here we go. Hang on, guys. It's up here.
Oh my God!
Oh, yes!
You saw that as well.
We both blew my mind.
Yeah, this is, I mean, like, look at us, we're like, yeah.
Can I just ask you to pop your hand out? If you pop your other hand on top, I'll grab the mic for a sec, okay? You're going to squeeze the cards nice and tightly in your hand now, because in a moment, all of the cards are going to disappear completely from your hands. Before we make the cards disappear in your hand and make this single card here, the 5 of spades, your selected card, look like it go, and it comes back one more time, okay? Did you just keep squeezing the cards nice and tightly, right? Did you feel the cards disappear when this card went? Are you sure?
No.
No? Look, 1, 2, 3. Every single card, believe it or not, completely disappears in your hand. Did you feel them go?
There was something that happened.
Okay, you literally felt it happen,
Something
right?
happened.
Please, lift your hand up for me. There we go. Every single one of these cards that completely disappears.
I don't get it.
I've never seen Lindsay lost for words, really.
I don't get it. Something happened.
Something happened.
Well, I don't know. I don't get it. Like, I just don't get it. Like, how on
That's
earth?
fantastic.
Well, thank you so much. Thank you very much.
Thank you so much, Dean. That was so
I
impressive.
don't want to do the next. I don't think I'm that. Wow, there we go. A round of applause,
Round of
please.
applause,
Dean,
everybody.
the posh magician. Way.
That was
I
wonderful,
can't believe
Dean. Thank
that.
you.
I was like, okay.
We'll be back later.
I'm a little bit astounded. Lee, I don't know if I'm ready to do the next interview.
I'm not sure I can follow on from that, really, Lindsay.
Oh,
There we go.
honestly, that was mega.
It was good. It was good. So,
Like, okay, I'm a little bit astounded now. Right, okay, so as astounding as the magician was, we're going to talk about Starrag as a brand. I love the fact that you bring a magician to your stand. That's brilliant.
Well, it brings something different, doesn't it? And we've tried not to be too conventional there. We're trying to tell a bit of a story about what we're all about. And of course, this guy brings the crowd, so it's great.
It's great. Now, okay, for anyone that doesn't know, we'll start this off, and I know there's quite a story here. Starrag as a brand, you're a strong brand in the business. When we went out to EMO, you brought some machines, but you can't bring all of your machines to a show, can you?
We can't. We had a bit of a dilemma about do we or don't we. We said this is about meeting and greeting people, and it's about letting people understand us. So a lot of our existing customers have come to see us, but we've met some great new people as well this week, which is really what MACH's all about.
So what's the story? Because Starrag, you have quite a few different brands, and for anyone that doesn't know who you are, can you explain Starrag as a brand? Because you represent so much in industry, don't you?
We do. Well, we look at several different key sectors, and you can see these on this image behind. So we've got sort of transport and industrial sectors, we've got precision machining, we've got the aerospace sector, we've got engine building, we've got the machine business itself here as well. So it's quite a powerful image, this, when you get close to it and you look at it.
The watch component.
And the watch components as well. So the variety of products we produce stem from micro machining with the watch components up to a machine that can produce a wing in a single setup or a huge energy part. So 300-ton table load down to micro machining.
It's incredible. And there's a theme that you've got to brand your company. So what's this orchestral theme then?
Well, the orchestral theme's all about the symphony and the synergies. If you look at an orchestra and all the different parts of an orchestra that have to be perfect, they have to work together, they all have to be harmonised together. It's exactly the same with our solutions. So there's a lot of engineering prowess behind Starrag, just in the machines. But then we have to connect that with a lot of automation and a system, and then we have to produce a solution to make the system work. So everything has to be harmonised, everything has to be in symphony, and that's the message behind the orchestral theme.
I love it. It's like creating music, and it's like seamless, and everything has to work and fit, and then you create magic, literally, when it's music. Yeah, exactly like the magician.
Exactly like that.
Brands then that sit within Starrag, can you just kind of, because you go by industry, you don't just try and push a brand, you're not just trying to put a machine on a floor, you're going for sector, aren't you?
We're going for sector, so there's two parts to answer that question. On the wall over there, you can see a load of names.
Yes.
So they're the brands that sit underneath the Starrag umbrella. So each one of those brands is a machine tool company in its own right. But then within those brands, we look at specific sectors. So I'll introduce you to Paul and Phil in a minute, but they're going to talk about specific sectors like aerospace and medical, transport and industrial, energy, super precision machining.
What do you think you do well?
I think what we do well is we deliver a complete solution for a customer. Very few people come to us and just buy a machine. They come to us with a challenge, a problem, something that's really hurting them, and then we deliver something that takes the pain away.
Have you enjoyed filming with Paul recently? Because he's come over to your facility, our boss, Paul.
Quite a lot of time with Paul this side of Christmas. In fact, I've spent more nights away with Paul than I have with my own family this year. So
I think you need a medal for that.
I need a break. I need a break.
Thank you, Lee, for giving us an overview. Is there any kind of lasting message that you want to say to people regarding Starrag in the UK?
Well, all I'd say to people in the UK is the perception of Starrag is we're really an OEM supplier, and we are. We also supply an awful lot of smaller companies as well, and people don't realise that. So come and talk to us. Brilliant.
Thanks, Lee.
Thank you.
Thank you very much.
Worries.
I'll take that baton from you. I'm still reeling from the magician. I just couldn't believe. I hope you're in as much shock as I am. Right. Okay. So we've got Chloe and Paul here to talk about one of the sectors that Starrag represent.
Hello, Paul. You all right?
Yeah, very well, thank you. How are you? And welcome to the booth.
Thank you very much. It's been quite a busy day for a Wednesday. Is your stand been busy?
Very busy, yes, very busy. I saw you enjoying the magician a little bit earlier.
Yeah, a bit too much. Absolutely. Right, here we're going to be talking about this part here and the parts on the table. We're going to start off with this bracket, should we say? That's what we were calling
Absolutely,
it, weren't
yes.
we? And we're going to be talking about the industry. So this is an aerospace part, correct?
Part, yeah. So I deal with the aerospace industry for Starrag in the UK and Ireland.
Okay, brilliant. So you look making parts like this. Is it a range, diverse of sizes that you're getting?
It can be, yes. I mean, this is typical for an aerospace type bracket. The material could be titanium, it could be Inconel, depending on which part of the aircraft it's going into. The whole purpose of this part is really very high strength with low weight, and that's why we use those materials. With titanium Inconel, they can be quite difficult materials to cut and very aggressive on tooling. So tooling costs are very important when you're machining these.
So talking about tooling costs and the machines, we were talking about earlier how it's more of a turnkey project, how it's the machine, the tooling, the applications as well that go into the whole process.
It is. From machine point of view, we've recently developed a new machine and added it to our range, which is a hydrostatic machine, which allows us to cut this faster without increasing the tool cost, because the hydrostatics absorb all of the vibration from the cutting and allows us to cut us quicker. Initial cuts for that machine was we actually used a 63mm diameter porcupine type cutter, 63mm deep slot in titanium, and it just cut it like butter.
No, that's absolutely fantastic. And moving on to this part here, sort of a blade, I suppose, isn't it?
It is, yes.
What materials are we using with this?
So again, it's various materials for blades depending on where they're being used in the engine. They can be titanium. They can be nickel alloys. Again, there's wide range depending on where they're being used within the engine. But we have specific machines for doing the blades, four of the engines, and also the containment casings.
Of course, because it's very important, isn't it, to be cutting the right material and then to have the machine be able to be capable of cutting that material time and time again.
Absolutely, yes. And the process needs to be very repeatable as well. So you need to be able to predict how long your tooling is going to last, because it's very important for your costs as well. If your tooling costs go up, the component costs go up.
Oh yeah, definitely, and it's a knock-on effect, really, isn't it, for a customer? And for these machines to be rigid enough and powerful enough to be able to do these components time and time again, it must give the confidence to the customer that it's a repeatable process.
Within the aerospace industry, the same as many of the industries now, the medtech and the automotive industry, everybody wants repeatable, forecastable processes. So you know exactly what's going on, they know how long the tooling is going to last, etc.
And if your customers know that you can do that, you're going to get repeat customers coming back. And especially with the applications from it as well, they know that you're clued up in this industry.
Absolutely, yes.
So we're going to move on to these parts now. We've been talking, these are really, really interesting for you guys to see at home. So we start off with this component here. Tell me all about it.
So this again, these are made on our Boomertech range of products, and the number or the name of the machine or the designation is the 191.
Okay.
And it does all of these products in its various disguises.
Of course, yeah.
So this, for example, would be implanted into the body, and pipes would be attached to there to supply the medicines in the exact amounts to the right part of the body.
So that can be put anywhere on the body where an infection or anything like that for the medicine to come. Catheter type part, brilliant.
This is a cervical spacer.
Okay.
So again, it's obviously used in the cervix. If someone's damaged the cervix, it needs to be repaired.
So these parts as well, they have to have a good surface finish on them, and they've got to last a long time, a lifetime really.
They do, yes, and generally they're made out of titanium or stainless steel, but there's a move now to move everything to titanium to keep the weight of the body down,
of course,
really.
Yeah. You don't want an excess of weight in your body to, if you have had an operation, to make you feel maybe not lopsided, but make you feel that weight in there.
Absolutely, yeah.
What's this one? Because this is quite an interesting part here.
Yeah, so this is it's a femoral ball. So this would be used within operations such as hip replacement. So that's part of the ball for the hip replacement. It's made out of cobalt chrome.
Okay.
The normal method to make those would be on 4 or 5 machines with 4 or 5 different operations. The Boomertech will take that from from cobalt chrome bar.
Yeah.
And 15 to 17 minutes later, depending on the size of the ball, it will be turned, probably 3 grinding operations, it will be polished, and it comes out complete.
And that's all on one machine?
All on one machine,
so you're taking
single operation.
You're taking it from 4 machines and quite a few different processes to having all those processes on one machine.
Absolutely.
So,
15 to 17 minutes.
Wow. So that would probably take 4 or 5 hours if you had all those processes to 17 minutes. Wow, that's incredible.
And the sphericity of that will be within 5 micron.
And the fact that that's made from a bar as well,
absolutely.
to then be turned into that dimension. Brilliant. This one here is quite interesting, Paul.
Yeah, this type of part would be used for minimally invasive operations. So, keyhole surgery. So that's a clamp type part. That's actually quite a large one. We go much smaller.
Of course.
We also machine the scissor type parts. We're doing the cutting during the operation.
Yeah. It's very interesting. And this one's quite commercial, isn't it? This one's more of a plate.
It is. This is the bone plate. Well, these are both bone plates. They're both made out of titanium. They're machined from bar on the machine.
Oh, okay.
So this is how they come out complete.
Complete, straight off the machine, right?
Absolutely, yes. This one is obviously a slightly different.
Yeah.
A sort of bone plate, where here you've got the grippers that need to go into somewhere to hold the plate in place.
So that's got a clamp onto something there, hasn't it? Yeah. And this one we've been talking about, which is really, very, very interesting. Yeah, Tell me the story behind this one.
So this would be used in the spline. It's made from a material called PEEK.
Yep.
And again, it's machined from bar. Very, very quick machining. Here, the interesting thing about this part is here, you'll see 2 holes. Now they have those holes in so that stainless steel bar can be put in there, because once it's in the back, they can't see that PEEK material in X-ray, so they need the pins in there so they can see where it is. But the Boomertech 191 machine, during the machining process, automatically inserts the pins and then machines the pins along with the part itself.
That's fantastic. So it does all that process on the machine. So when that gets slotted into your back during an operation, the only way that it can be picked up is through these pins
through
here.
The pins, yeah, it's a standard thing, yes.
Wow, that's amazing.
It's quite standard, but the Boomertech 191 machine is a very, very flexible machining platform.
Well, it's able to create all of these different sizes, different orientations of parts. So it's just incredible.
It's the materials as well. The materials we deal with in the medtech industry can be anything from titanium, stainless steel, PEEK, polyurethane, particularly for knee implants and things like that, right down to coral. We even machine coral to go into the body. Yes.
What's the advantage of coral?
It's a very good material to use on some bone replacement parts.
I didn't know that.
It actually joins to the bone very well.
Yeah, okay.
It's very unusual.
It is very unusual, and that's given me an insight, actually, on what we're doing. Thank you so much for your insight, Paul. I really enjoyed talking with you. I'll just take this mic now, because we're going to pass over to Lindsay and Phil on this part, and they're going to be talking about some different industries that I've been talking about.
I'm still reeling from the magician, Chloe. I just don't get it. But we've got to get this right. Phil, thank you for going on camera.
Thank you.
How's Mac for you?
Mac's been brilliant so far.
How are your feet?
Oh, my feet are great. And then I don't know whether you've heard the secret of the comfy shoes.
Oh, well, there is that. Right, Phil's going to talk to us about a slightly different area of the Starrag business. So what area do you head up in UK and Ireland?
Well, I jokingly say that if it doesn't fly, it's me.
Okay, that's fine.
Whereas my colleague Paul is focused on aerospace and particularly also in the precision medical sector.
Yeah.
For me, it is everything to transportation, industrial, power generation, energy components, small precision components, scientific, electronic machining.
You know what I really like? There we go. Phil, what I really like, but off camera, Phil's just been chatting to me, and you know, I like the fact that I was talking about other brands with Phil, and I like the fact that we both agreed everyone's good at certain areas within this industry. And, you know, I said about a couple of other brands and you were like, no, I don't think they do this, but if you want to go to them, they're good for that. So what is it that people should go to you for?
Our specialisation is in milling machines and milling technology, from literally parts that you can hold in the palm of your hand that are sometimes smaller than the swarf, through to components that would literally fill this stand as we stand.
And you can't bring in a machine.
And we can't bring in the machine.
That.
We certainly can't bring the parts.
You were just talking about parts the size of your hand that you said. Can you just take us through some of these components?
There's some tiny little watch components here. So a watch plate, I think that's fairly obvious. It's a mechanism plate, but then you get tiny components like this, hopefully scaled up to the size of my fingernail. The barrel, which would encapsulate the mainspring for the watch. These all come off of our small Boomertech machine. You'll have been looking a little earlier at medical parts. But
and it's speed. It's speed for you.
It's speed, but it's also precision.
Yes.
And it's finish.
Yes.
So there are features on these tiny.
You can just turn that round.
You won't see it, but there are tiny teeth on there that have to be very precise because they're part of the gear train mechanism of the watch. You might catch a sight of them. I don't know how good the camera resolution is. If I move it around, you can see them glinting, perhaps. We also, watches is what we call a luxury goods, and it's not so big in the UK, but it's a really growing sector, actually, UK watchmaking. So we're very, very keen to show the technologies that we can bring to that. Then, for us, a big area for us is the scientific sector. So here we have a part that's actually part of a microwave waveguide. It's a transmission part. Some of the dimensions on there are so small that they cannot be measured. The only way you can measure them is actually by putting the microwave frequency electronically through it. No, I'm not kidding. You have to put the microwave frequency through it. If it comes out correct the other side, then the part is correct.
I've never heard that before. I've literally
well, if you can
never
see
heard it before.
That what looks like a scribe line up the centre.
Yes.
Yes, that is a precision groove.
Wow.
And that affects the ability of the frequency to pass through that component.
I've never heard that before.
That finish that you see on there that's glinting, that is how it comes off the machine.
Really?
And the threads here that you'll notice,
this is the
complete component, but the component has to be made in two halves. So we actually precision thread mill these in halves, and when you make the two parts together, the thread is perfect.
You know what I love about this? You come to MACH and you see all these big wow stands. Can I just say, the cameraman behind just went, that's really cool, like that is proper cool, that's really cool, that is Lynn.
But what I do want to emphasise, that's just one end of our production.
Yes.
Where we really core is in a lot of components like the size of this one. So this is a component from something like a tractor gearbox.
Yes.
Made complete on a Heckert mill turn machine. So you've got turning, you've got milling, you've got gear cutting, you've got hard turning. This is a bearing surface. This has been hardened. This is probably something like about 58 Rockwell.
Wow.
Very, very tight tolerance and very close tolerance threading as well in the end. That will have been made complete on one machine.
It's impressive.
In one, possibly two operations. But this is the kind of thing we're also very good at. So large transportation machinery, so like earth movers, diggers, tractor gearboxes, hydraulic machines, like hydraulic components that drive braking systems, that drive hydraulic motors in small diggers. That's one element. Industrial components generally, anything that can fit on a Heckert mill turn, and by that it's a milling machine that has full turning capabilities as well as being a full 5-axis milling centre.
I've said this already, you're not about just putting a machine anywhere, are you?
No.
I think that's what, I think the takeaway from this is to say it's about speaking to Starrag and seeing what you're capable of, talking through the whole process.
Now, it's very easy. A lot of people say, we provide a solution. Well, we do. But what we do at Starrag is we provide a holistic solution whereby the solution is what we deliver. The machine tool is part of that solution.
I like that.
We actually drive it by, customers don't come to us and say, I want this spindle, I want that table.
No.
They say, I've got this part, I have a problem, I need to make it quicker, better, cheaper. There will be a whole range of drivers for the business to be able to make this part quicker.
It's about the people and the intellect behind it all, and then there comes the solution and the machine.
And what you're buying is Starrag's expertise. Starrag's world-class engineers. We have world-class engineers both in the UK and at every plant of all of our product ranges, and you have to bear in mind, we've talked about small parts. We go up to machines that are 48 metres long and take a 300-tonne casting.
Yeah. You can't even imagine it, can you? I was going to say this earlier, I love it. You come to MACH and you've got all of these halls, right? All of these great, big, amazing stands. But something like that will be remembered. And it's something so tiny that you cannot even measure it when it's in use and going through a microwave. And yet, that is what is incredible about technology in this show, really.
So this is in 5G 5G masts, the new 5G networks. These are what these components are being made for.
It's amazing.
But as I say, transportation, energy production, steam turbines, gas turbines, there are so many areas we're involved in, and we have so many machine technologies, vertical turning machines with up to 14-metre diameter table.
So Phil, can we get some of these components on the stand, like these really great big ones, and then
Well, I could probably do it virtually, but I can't physically.
No, we can't.
Because they are too big.
They're too big.
Literally, when you're talking a bearing for a wind turbine that is 11 metres in diameter.
They wouldn't get it in the halls.
We could get it in the halls. Nobody would be able to get on the stand.
No, we wouldn't. There would be no tea, there'd be no coffee.
Oh, no, we couldn't do without that.
Brilliant. Okay, well, thank you, everybody. Thank you, Chloe.
Thank you.
How are you feeling? Thank you, Phil. I'm going to pass
It's
the baton back on to Chloe just
Thank you, Phil.
to finish this up. Thank you. Really, I'm absolutely wowed by that. I'm wowed by that.
I'm wowed by that.
We're both wowed together.
The materials that they are cutting, coral, like that is just blowing my mind. I'm going to go home and research where these coral farms are. Why are they using coral? How are they cutting coral? These 42-axis machines that are making stuff for the jewellery industry as well. And why are they using it? Why are they turning things from bar to make these sorts of parts? Why aren't they using billets? And some of the materials that they're using, like gold and silver, these metals, they can't use coolant because they need to save the chippings to melt down. And it's all the processes. Yes, you do get this finished part, but it's all the processes after that they're thinking about. And it's got my mind going crazy.
Well, Chloe, I think it's safe to say Chloe's got a busy night Googling all of that.
I think I'll be going to bed very late tonight.
Yes, she will. Thank you, everybody, for watching. We're on the Starrag stand. We're going live. Keep watching our live shows throughout the day. This has been good, and I'm still pretty amazed.
I think we need to go and have a nap.
I think we're going to have a nap. Stay tuned.